Hey everyone, we're going to work through problem 2.20, A and B. This comes from chapter 2.3, the energy section in your book, and it goes along with energy, which is basically the ability to do work, but we also talk about heat. And heat is thermal energy, so it's energy in motion or the motion of particles. And we're going to look at the two different units of energy. There's joules, and it's pronounced as joule, just like you might have a ring with a jewel in it, or however you want to think about it. But you also have calories, and so we're going to look at both of these units. Okay, but basically this first part is this really not that difficult. Students don't have too hard of a time with these problems, but I just want to be sure that nobody gets them backwards and they see how we are converting. Okay, so basically it goes back to our conversion factors, it goes back to dimensional analysis and converting. So what we're going to do is, one second here, we're going to convert. We're given that we have 750 kcals, so a person uses 750 kcals on a long walk. Okay, so that's what we're going to start with. And we want to know how much energy is used for this walk in the units of joules, and then we're going to look at kilojoules. Okay, so the main thing that we need to know here is that 1 calorie is equal to 4.184 joules. That's our biggest conversion factor, or what we need to use for this problem. So if we have 750 kcals, okay, we run into another problem. Okay, we are in kcals, but our conversion factor that we have here is in calories, not in kcals, not in kilocalories. Okay, so we have to also know that 1 kcal is equal to 1,000 calories, which shouldn't be too surprising. The kilo means 1,000. And we also want to know that 1 kilojoule is equal to 1,000 joules. Okay, so the first thing we have to do is convert from kcals to calories. So in 1 kcal there are 1,000 calories. And now we have calories on the bottom. So now we're going to put in our conversion factor, so we can look at it as 1 calorie or okay, and we're going to use the second ratio that I've shown here because we need calories in the denominator. So we're going to put our joules there, so calories cancel, and we are left, tells us to report to 2 significant digits, I believe. So our answer, we get a large number of 3.1 times 10 to the 6 joules. Okay, part B says to convert to kilojoules. So we already can go, you can just add a step up here, we can just add a step in there, or we can just take what we just found. So we just found joules, and we need to convert to kilojoules. So we know that there are 1,000 joules in 1 kilojoule. We're going to get a smaller number here. We're going to divide by 1,000, and so we end up with 3.1 times 10 to the 3rd kilojoules. Okay, so it's very, very similar to what we were doing in chapter 1, but this time we're just using different units. So we're using units of energy. So the main thing you have to remember here is 1 calorie is equal to 4.184 joules.